All right, so we got some time distance problems to go through. It's actually kind of fun to actually apply what we've been learning. First thing I would want to talk about is we have this really nice example that has a table, and this table is going to be your best friend when it comes to these problems, because it's going to organize your data really nicely, and then you know that there's going to be a cue in the text on a relationship with this, and a lot of times you're just going to be able to set things equal to each other or have the sum of these two equal something else. So that's really the cue that you need to be looking at, making a nice table. Time times rate equals distance. So I'm going to do number 2. We have 2 camper vans leave Arrowhead Lake at the same time, one traveling north. I'm going to draw this, traveling north at a speed of 10 kilometers faster than the other, which is traveling south. And hold on a second, so I'm going to say this is 10 faster. And so my other one is traveling south, and which is traveling south after 3 hours. So my time is going to be 3 hours. After 3 hours, the camper vans are 240 or 420 kilometers apart. 420 is a nice number because it has a lot of factors, makes it easier to write problems. Find their speeds. So I'm going to make my little table. So I know that time times rate is equal to distance. And so I have my north one, excuse me, and my south van. And I know that my time for both is going to be 3 and 3. And I know that my rate for the northbound one is going to be the speed of the southbound one plus 10. And of course I didn't give myself enough room on my table, which means that my rate for the other one is just the speed, which then means that my distance is going to be rate, or time times rate. So I am going to need to give myself more room, so I will do that. So you can read that. Of course, if I was a thinking man, I would have erased that the first time too. All right, so we have 10 here. So then my distance for the northbound one is going to be the 3 hours times my speed plus the extra 10. That's funny, didn't leave myself enough room again. And then for my southbound one, it's just going to be 3s. And I know that since this one's going north and this one's going south, that the distance that the north one has traveled plus the distance that the south one has traveled is going to equal 420. So that means the speed of the distance of my northbound one, that's an s plus 10, plus my speed. I'm just having lots of troubles in terms of keeping things in the right place. I have lots of erasing. Not the cleanest video I've ever made. And we know that's going to equal 420. So let's go ahead and resolve this. So 3 times s is 3s plus 30, because that 3 has to be distributed to the 10, plus 3s is equal to 420. So then, yes, that is a 0. So now we just combine similar terms. 3s plus 3s is 6s plus 30 is equal to 420. Subtract 30, subtract 30. So that means, and I'm going to have to work over here, that 6s is equal to, well, 420 minus 30 is going to be 390. And so now we can go to our calculator. 390 divided by 6, 65. So that means the speed of my s is equal to 65. So that means my my southbound one is going at 65 miles per hour, and my southbound one is 75 kilometers per hour. I was going to say 75 miles per hour is awfully fast for a camper van. But But you see how this table really helped things move along. So if I go to my next page, I'll do one on this side. I have another really nice detailed explanation in this box. Please read it. It will help you. And again, it's the same kind of table that's going to help you. So 6 is due, so I will do number 5. A tourist leaves Richmond at 1 p.m. for New York City. So I'm going to just write that 1 p.m. Just pulling information out. Exactly 24 minutes later, a truck goes in the same direction. So that means at 1:24, I'm going to say this is the tourist, and this is the, of course, truck starts with, oh, so that's a bus. Let's call this a bus. And then a truck moves at 1:24. The tourist bus moves at a steady speed of 60k, and the truck moves at a steady speed of 80k. When will the truck overtake the tourist? Well, so we know that rate times time equals distance. Let's see if I learned from my previous mistake. And so we have our bus, we have our truck. The rate's going to be all right. So the rate here is for the bus 60. My rate for the truck is 80. I don't know my time, right? So the bus is just going to have time t. But the truck doesn't have the same time, right? Because it left 24 minutes later. So it has the time minus the 24. See, now I'm getting smart. And when they meet, they have the same distance, right? So I know 60 times t is 60t, and I know that I have 80 times my time, which is t minus 24. And I know that the distance of my bus and the distance of my truck will be the same when they come together. So I'm going to say that 60t is equal to 80 times t minus 24. And so now it's just a matter of solving this. 80 times t is 80t. Minus, I don't know what 24 times 80 is off the top of my head. I could probably do it, but here I am being lazy. It's late. Sorry. 24 times 80. That's a big number. 1920. No, I was not alive in 1920. Not that old. So now we have, well, we've just solved it. So what's the opposite of positive 80t? Negative 80t. So I'll subtract 80t from both sides. So I get negative 20t is equal to 1920. So divide by negative 20, that's negative because it's negative, right? So divide by negative 20, divide by negative 20. So I can cross that out because 10 divided by 10 is 1. So then I have 2. How many times does 2 go into 192? Well, so I get the time that the bus was driving is going to be, that goes into it 9 times, carry the 1. That goes in 6 times, no carrying, and a negative divided by a negative is a positive. So at what time do they cross? I believe that's what it's asking. We'll wait for it to move. There we go. How long does it take the truck? So it only asks how long does it take the truck. Well, it takes the truck. So the bus has been driving for 96 minutes. The bus, sorry, t, that's the time. So this is in minutes. And so the truck left 24 minutes after. So you gotta subtract that out. And so you get 2 and 7. So it took the truck 72 minutes to overtake the bus. And that's basically all you do. Again, the key for these problems is this nice arrow, that table. All right. Area problems. Dude, I love area. Actually, area is a really big deal when it comes to what we're doing now in CMP. terms of quadratic relationships. It's a good way to understand it, which is exactly why they do this here. So again, great example problem. Please read it and try to understand it. It will make your life better. And that's just one big example problem. So if I go to the next page, I'm supposed to be helping my son's basketball team right now, but instead I'm doing this. So I'm just kind of trying to get this done quickly. All right, so let's take 5. A rectangular fish pond is 8 feet longer than it is wide. So I have a rectangular fish pond. Here's a fish. It looks like an infinity symbol. There we go, there's the fish. Goldfish, cheddar flavored. And so it says that the pond is 8 feet longer than it is wide. So if this is my width plus 8, because it's 8 feet longer, right? And then it says a wooden walk 2 feet wide is placed around the pond. So that means this is 2 feet, this is 2 feet, and I can do that all the way around. So now this width, this whole width here, is going to be this w plus 2, which is 4. So this width, anytime now, is going to be w plus 4, because I have my walkway, which means this is now w plus 8 plus 4, which you'll tell me is plus 12. And so then it asks, the area covered by the pond and walk is 160 feet greater than the area covered by the pond alone. Oh, well, so that means my green minus my orange, I'm really big into pictorial diagrams, it really helps, is going to equal 160. Oh, well, that's not too bad. How do I find the area of a rectangle? Well, I multiply the base times the height. So my base of the green is going to be w plus 12 times the width, or the height, which is w plus 4. And then I'm going to subtract that by the width of my original, which is w, the width, times w plus 8. Oh, aren't we glad we learned how to multiply polynomials now? You're probably thinking no, because then I wouldn't have to do this stupid problem. That's not what I wanted to do. See, the later it gets, the snarkier the comments get. All right, so I'm going to rewrite this. W plus 12 times w plus 4. W times w is w squared. W times 4 is 4w. 12 times w is 12w. 12 times 4 is 48. So add straight down, so we have w squared plus 16w, and that is a 16, right? Plus 48. Okay. And so then my other one, I'm going to do this here. W times w is w squared. W times 8 is 8w. So then I'm going to subtract this whole thing, w squared plus 8w. And that whole thing, watch, this is my favorite part of the board. I'm going to select all of the writing and shrink it. And now I have plenty of room. So and now it's all green with envy. So this is going to be equal to my 160. So what is w squared minus w squared? Well, they just cancel out. What is 16w plus 8w? But that's not plus 8w because I have this pesky subtraction sign. What is 16w minus 8w? That would be 8w. W. That's not w. I still have my plus 48 because I have no other numbers to combine it with. Oh, so this is something I can solve really easily. The opposite of adding 48 is subtracting 48. So I have 8w is equal to, gotta borrow, 112. The opposite of multiplying by 8 is divided by 8. Divided by 8. And so I pull up my calculator. So the width is now 112 divided by 8. We're hoping that it's a whole number. Yeah, 14, look at that. So my width is equal to 14. All right, so again, just like any video, stop and start it as necessary so that you can get it done and do your own problems. And obviously we have tomorrow to work on it too. There's extra help. I'll see you tomorrow.